Our last lesson on blood is blood types or blood grouping. Now, blood type refers to the type of proteins or antigens that are on the red blood cells. They're technically found on the lining of the red blood cell. And blood types, here's how they were. Well, first of all, they were discovered by Carl Landsteiner back in 1901. And what he found was that there was these molecules that are called antigens now, and that there were two of them that he found on the lining of red blood cells. And so the blood types, and he called this type of grouping, he called it the ABO grouping, because blood type is determined by the presence or the absence of these molecules on the membranes of the erythrocytes, these molecules being called antigens. Now, why is an antigen important? And I'm just talking about the blood antigens. There are other antigens as well in our body, but we're just talking about the blood ones. They stimulate the production of antibodies. That's their job. So their specialized blood cells produce these antibodies, which are located in the blood plasma. So our blood types are determined by the presence or the absence of the antigens. And Carl Landsteiner, he called antigen A, one antigen A, and he called the other one B. And we'll talk about then how do you get those different blood types. But the first thing we need to know is, why is it important to know your blood type? Well, one very important reason why is in blood transfusions. And in a blood transfusion, there is a person who is giving their blood, and then there's a person who is receiving that blood. The donor, you need to know, is the person who gives the blood, and that's pretty easy. When you donate something, you give. The recipient is what the person is called who receives the blood. So there's a donor and a recipient, and it's very important on what their blood types are, because if you give the wrong blood type to the recipient, it could kill them. And it did, way back before Carl Landsteiner. So there are two blood type classifications, and they are the most important in blood transfusions. They're also important like in organ transplants. That's another reason that they are important. It's also important in the birth, like a married couple, where the woman is one blood type negative and the father is positive. That's important to know about their baby. So we're going to talk about these two systems, the ABO first, because it was the first one discovered, and then the RH system. And as I was telling you, it was discovered by a man called Carl Landsteiner, and you need to know that, in 1901. So he found two antigens on the lining of red blood cells, erythrocytes, and he called those antigens antigen A and antigen B. So the blood types, according to the ABO grouping, are whether we have the presence of antigen A and or antigen B, or we don't, the absence of them. So let's look at the four different blood types according to the ABO grouping. If I have the presence of the A antigen, but I do not have the B antigen, I am type A blood. If I have the B antigen, but do not have the A antigen, I am type B blood. If I have both of the antigens, I am type AB. And if I have neither of the antigens, I am type O. And the most common type is O. And I am O positive, so I have type O. I don't have antigen A, nor do I have antigen B in the lining of my erythrocytes. So that's how blood types are determined. So according to the ABO grouping, we have 4 blood types: A, B, AB, and O. Now let's look at why it's important in blood transfusions. If you're type A, which means you have the A antigen. Now remember, what do antigens do? They stimulate the production of an antibody. So they're not the ones that make the antibody, they're the ones that send out the message for the special cells to start making it. And so what it's going to produce then is what is foreign to it, the B antigen. If somehow B blood got inside a person who is type A and doesn't have the B antigen, that B antigen is foreign to it, so it's an intruder. And your body then tries to destroy it. And so it produces anti-B to fight against the B antigen. Anti means against. So it's fighting against. So how does it fight against? It actually adheres to it, and it's called agglutination, where it's not really a clump or a clot, because a clot is different. We looked at that when we were looking at the red blood cells and one of the the platelets and one of the jobs that they do and why they're needed. But it's that effect where they clump together, they stick together. And so imagine a bunch of those sticking together in your blood vessels. And what's that going to do? Clog up your blood vessels and cause death. Now, if I am type B blood, it means that I have the B antigen but not the A. So the A is an intruder, it's a foreign, it's an enemy. So my body, the B antigen, it's going to stimulate the production of anti-A to fight against the A antigen. How does it fight? Again, by sticking together with it, clumping it up. Now, if I have both A and B, neither are foreign to me, so I'm not going to have any blood antibodies. Otherwise, they'd be fighting against my own blood. Now, me being type O, I have neither antigen, so they're both foreign to my body. So my body's going to have anti-A and anti-B antibodies. Now, let's look at where they are. These are things that you need to know. Antigens are in the red blood cell membrane, erythrocyte membrane. Antibodies are inside the blood plasma. According to the ABO group, the most common type of blood, which you need to know, is O, and the rarest type of blood is AB. Now here's showing you, I like the graph that they have here. If you are a type A person with blood type A, you have anti-B antibodies, and you have the A antigen. So this is just like in a diagram illustrating what I just told you. You don't need to know any of these statistics, but this is to give you an indication of how rare or how common your blood is. If you're A, 40% of the population is A. B is only 10%. AB, the rarest, is only 4%. And O, the most common, is 46%. Here's another picture, and you can see how they're called agglutinin and agglutinogens. We're just going to refer to them as antigens and antibodies. That's easier, and you can see that on the side there. Here's why they're important. If I'm type A blood, I can get A blood, and obviously in emergencies they're going to try to give you the exact same amount, same type of blood you have. But the problem comes in when they have catastrophes like earthquakes, tsunamis, or even like when the Twin Towers fell. There are a lot of people injured, and therefore there's a lot of blood needed, and maybe they run out of A. Well, the neat thing is, because O doesn't have any antigens, O can be given to any type of blood. So A can receive A and A can receive O. Why can't it receive B? Well, remember, what does the A blood, what antibodies has it developed and produced? Anti-B. So as soon as they're given B blood, their body's going to attack it and it'll kill them. Now, if you're type B, you can receive B and you can receive O, but you can't receive A. Now, what about A and B? Could they both receive the AB blood? No, because if A got AB, it still has B in it. If B got AB, it still has A in it. So again, it would attack it. But it's neat how God works. The rarest type of blood, AB, look at what they can receive. Obviously, they want, in preference, AB. But in emergencies, they can use A, B, or O. And because of that, type AB blood is known as the universal recipient. Can receive all types of blood. And it's the rarest. So it's neat the way God works. And then the most common blood, O, can only receive itself, O, and no other one. But it's the most common, so there's more of it to go around. So it's pretty cool how God works and how He created all this. Here's another. I like to use pictures, and this is showing you the percentages, and it's using some diagrams there to show you the antigen, which is in the lining of the red blood cells, the antibody that's produced by or it's stimulated to be produced by the antigen, and then showing you which bloods they can receive and which bloods they can donate to people. Now, the first successful human blood transfusion was accomplished in 1818. Now, think about that. Way before they knew about blood types. By James, how do you say that? Blundell? You don't need to know that fact, but that was the first successful. They had a lot of unsuccessful, and they had a lot after that unsuccessful because they didn't know about the antigens in the lining of the red blood cells. So this guy, pretty lucky. You do need to know that the universal recipient is type AB and the universal donor. The universal recipient can receive all blood. The universal donor can give their blood to all blood types. Now, Carl Landsteiner found something else. I think it was about 35 years after he found the first two antigens. He actually found another blood antigen, and he found it in a rhesus monkey. So he named this blood system after the monkey that it was first isolated in. And he called it the RH system because rhesus is spelled with an R and an H. And it too is based on the presence of having the RH antigen or not having the RH antigen. If you have, you're positive. If you don't have it, you're negative. So there's only two types of blood using just the RH system. You either have the RH antigen and you're positive or you don't have it. Most people have it. 85% of the population. RH negative is rare. Only 15% of the population. So when you put the two blood system groupings together, the ABO and the RH, you have 8 types of blood. A positive and A negative. B positive and B negative. AB positive, AB negative, O positive, O negative. So in looking at that, what would be the most common blood? And you need to know this, O positive. What would be the rarest blood? AB negative. And here shows you 1% of the population being AB negative. But O negative is only 7% because all the negatives are going to be low because only 15% of the population has negative blood. Now I'm going to get into blood typing. You don't need to know this for the quiz, but we are going to be doing a blood typing lab. And when we do a blood typing lab, you'll get one of those plastic cards that has 3 wells in it, and they're labeled A, B, and RH. You're going to get one of the trays. You're going to get 3 toothpicks because there's 3 wells, and you're going to take a vial of blood, and you're going to put 1 to 2 drops of blood in each well. And remember, always replace the caps when you're done with one before you open the other. That way we don't have any contamination. You obtain a blood plastic tray, 3 toothpicks, and what you're going to do next, or you already have that, excuse me, you're going to get the anti-A serum. Now what does anti-A serum have in it? Anti-A antibodies. So anti means against. So what is it going to coagulate with? What is it going to agglutinate with and get all sticky and clumpy? It's going to do that with the A antigen. So if I put a drop of anti-A serum into one of the wells and I mix it up and I see little clumps everywhere, that's a positive reaction. So that means, yes, there's the presence of the A antigen. When I use B in the B well and mix it up, if I get a positive reaction, meaning I get those little clumps, then I know it has the presence of the B antigen. So then I try RH. And let's say when I add the RH, which is also called anti-D, and it doesn't clump, that means the presence of the RH is not there. So that would be negative. So what would that person have if A was positive test, B was a positive test, and the RH was not? You have type AB negative blood, the rarest blood. What if all 3 wells do not have any reaction? So no clumps in any of them. That is O negative blood. Okay, what if the A clumps and the other 2 wells do not? What type blood would that person have? A negative. What if the A well clumps and the RH clumps, but not the B? That person would have blood type A positive. And that's how these work. So you can mix them with different toothpicks. That way you don't have any contamination. And you're going to look at your blood. And see, this is an example of what your card will look like. And notice in B, see all those little specks in there? That's that agglutination. That's a positive reaction, meaning that person has the presence of the B antigen. So looking at those 3 wells, what type of blood does that person have? B negative blood. Now look at the sample up here. You had the A well clump and you had the RH clump, but not the B. So what type blood would that person have? A positive blood. And here's some other examples. Look at the first one. Now they used R. I have no idea, I guess, for RH instead of writing the H there. But A positive, R positive, so it's A positive blood. B reacted, the other 2 did not, that's B negative blood. Only the RH reacted, so that's O positive blood. And the last one, the A and the B reacted, so it's AB negative blood. And that's how you're going to type blood when we get to the lab.